Can a single piece of aerodynamics make Ferrari the team to beat in 2026? What they are testing right now in Maranello is not just a spoiler. It is a paradigm shift that could redefine the races in the modern Formula One. In full preparation process for one of the most drastic technical reforms than Formula One has experienced in the last 20 years, Ferrari has decided not to interpret the 2026 regulation on paper. The Scuderia is going on track with a clear strategy to advance to the rest in the development of technologies that, in practice, could redefine the way in which a car is piloted. During the Pirelli 2026 tire tests in Hungary, they did not take a car to simulate next season, but a rolling laboratory. A modified SF25 until the last detail, turned into a mule car with the mission of trying a concept that until now seemed reserved to science fiction within the hybrid era, a front wing with active control in real time. The detail is not less. The FIA, aware that this piece will be key in the balance of the new cars, issued a specific technical directive that authorized the teams to experiment with an actuator to act the front flaps in a controlled way. Ferrari soon took advantage of this window. What seemed like a more test session became an essay at the semi-absence door of a strategic weapon, where the opening and closing of the flaps was not decided in boxes before the race, but passed to the direct control of the pilot in the straight or at the entrance to a curve. It was no coincidence that the one chosen to release this system was Charles Leclerc, one of the most sensitive pilots to aerodynamic behavior of the car and capable of transmitting technical feedback surgically to their engineers. According to technical sources, in Budapest he could be the first pilot in decades to act a truly active frontal system in competition conditions. This opens an important precedent. It is not a predefined adjustment, but a continuous return adaptation, sector to sector, something unpublished in the modern F1. The bet was even more ambitious. Instead of limiting the active wing about the usual suspension architecture, Ferrari radically changed the configuration, moving from the pushrod scheme to the pull rod in the front train. The objective was double. On the one hand, evaluate how the new geometry could be integrated with the active wing to reduce turbulence and optimize the airflow to the flat bottom. On the other, more precise simulating the expected behavior of the 2026 car, which is already projected with that suspension as a base. The system that Ferrari is developing is not simply an opening and closing mechanism of flaps. It is a central piece of an active aerodynamic concept that, in practice, will allow the car to behave as if it had two different configurations in the same lap. At its base, the device combines sensors, actuators, and advanced electronic management to modify the attack angle of the front spoiler in real time, all synchronized with the behavior of the rear wing to maintain the aerodynamic balance of the car. The operational logic of the system is articulated in two predefined but immediately activated by the pilot: the Z mode and the X mode. In the Z mode, the car adopts a high aerodynamic load configuration. Here, both the front and rear winging close its mobile elements to maximize the pressure on the asphalt, which significantly increases lateral grip and curves braking. This mode will be crucial in slow and technical sectors, where traction and stability when entering curve make a difference. On the other hand, the X mode seeks the minimum possible resistance. The front and rear flaps open, reducing the aerodynamic load to allow the car to cut the air with less opposition, increasing the peak speed and reducing energy consumption. Authentic innovation is in the strategic flexibility it offers. Until now, the equipment had to compromise the aerodynamic configuration to a complete circuit, choosing between a high load setup for scrambled clues or a low load for traced with long straight. With this system, Ferrari can adapt the car to the characteristics of each sector without compromising its global performance. This means that in the same path, such as Spa-Francorchamps, you can attack Eau Rouge and Pahon with the maximum load in Z mode and then exploit the X mode on the Kemmel line to win kilometers per extra hour that would be impossible with a fixed spoiler. The benefit is not limited to pure speed. With the regulations of 2026, the power units will have an energy distribution of 50% between the combustion engine and the electrical system, which implies a much more accurate management of the energy available by return. The X mode, by reducing resistance, will require less power to maintain the same speed in line, allowing fuel and release electrical capacity for other strategic points of the circuit. On the other hand, the Z mode will allow maximizing regeneration in braking, taking advantage of the high load to stabilize the car and transfer more energy to batteries. In addition, the system opens the door to a new type of strategy in the race, where active spoiler management is combined with tire tactics and energy management. Under traffic conditions, a pilot could be kept in Z mode to defend position in technical sectors and then change to X mode to prevent the rival from benefiting from the rebuild in the lines. In classification, the timely use of the X mode in key areas could mean winning those 2 or 3 tenths that today make the difference between leaving in the front row or being trapped in the second line. Ferrari is working for the passage to another to be imperceptible to the pilot in terms of equilibrium of the car. This implies a fine control of the pressure on each axis, something that requires perfect integration between aerodynamics, suspension, and electronic systems. The challenge is capital. Any lag in the activation could cause sudden survival or subviring to more than 300 km/h. But if they dominate it before its rivals, this system will not be only a technical advantage, but a tactical weapon that could decide championships. Integrating an active front wing in a Formula One car is not only a design challenge, it is a technical and operational puzzle that implies rethinking the way in which each car component interacts with others. Unlike a fixed aerodynamic element, whose behavior is predictable and stable throughout the lap, an active system introduces a dynamic variable that changes in thousandths of a second. This forces to emphasize the suspension, the distribution of brakes, energy management, and even the engine mapping so that all systems work in perfect harmony every time the wing modifies its angle point. One of the most complex challenges is to guarantee the consistency of aerodynamic load in borderline situations. A synchronization error, however, can alter the stability of the car in critical phases such as braking at the end of a line or the entrance to a high-speed curve. If the front wing passes from a low-resistance position to a high load with a lag with respect to the rear, the car could become unpredictable, generating sudden subverging or survival. This not only would compromise performance but would put the security of the pilot at risk. Therefore, the development of this system requires an ultra-trunk and reliable electronic control, capable of anticipating the movement of the car and adjusting the wing proactively, not reactive. The potential impact on Formula One is deep. A team that dominates this technology could make a sector-to-sector differences, creating a new competitiveness pattern in which it is not enough to have a fast car in general terms, but one capable of adapting in real time to each area of the circuit. This would not only benefit pure performance, but would open the door to much more complex career strategies, with configuration changes that could respond to the evolution of the track, to meteorological changes, or even to the rival movements. Ferrari, being the first to take it to the track tangible, is gaining an advantage that is not measured only in collected data, but in operational experience. Each test session allows them to refine not only the mechanical and electronic part, but also the communication language between engineers and pilots to exploit the system to the maximum. If they manage to refine it before the rest of the grille reaches a similar level, they could start the 2026 season with a strategic tool that forces everyone to run under their rules. In a championship as tight as the one that is projected, this could mean starting with a real advantage of several tenths, enough to change the course of a World Cup before reaching the middle of the season. If something has demonstrated the history of Formula One is that the great technical revolutions rarely arrive accidentally. There is always a team that advances the rest, which assumes the risk of investing time and resources in an idea that, in its early stages, seems uncertain. Today, that role is playing Ferrari with the development of the active front wing. It is not a simple experimental piece, it is a declaration of intentions. The Scuderia is sending a clear message to the rest of the grille, and it is not intended to wait for the 2026 regulations to become a reality to start working. Its plan is to arrive with advantage, with a proven, optimized and ready system to make differences from the first race of the new era. The relevance of this movement is not limited to the technical part. In such a competitive championship and with such tight margins, any innovation that allows extracting extra performance without compromising reliability becomes a decisive factor. An active wing, perfectly synchronized with rear aerodynamics, could redefine the way the career strategy, car settings, and even the preparation of the pilots are conceived. In the same weekend, Ferrari could be able to adjust its focus on the characteristics of each circuit, avoiding the eternal dilemma of compromising the peak speed to earn grip in curves or vice versa. In addition, the experience they are accumulating right now on the track has an incalculable value. It is not just about to collect technical data, but to train the entire team in the management of a system that requires perfect coordination between engineers, mechanics, and pilots. The sooner these processes are integrated into the daily operation, the more natural it will be for Ferrari to exploit their potential when the regulations enter into force. And in an F1 where each tenth account, reaching 2026 with the learning curve already overcome could make the difference between fighting for victories from the beginning or spending half a year trying to catch up. The potential impact of this development goes beyond the Scuderia. If the system proves to be effective, it will force all other teams to accelerate their own research programs, generating a real technological career even before the first traffic light of the 2026 season is extinguished.